Hello and welcome. I'm in conversation with Akshay Singhal, CEO and founder Log9, at the very auspicious occasion of their cell manufacturing facility launch. Congratulations, Akshay. And I believe this is the first facility of its kind.
In India and presumably in Southeast Asia as well.
Oh, that's amazing. So, the big question for everybody out there, I've heard you speaking a little earlier, is so are you really manufacturing the cells? Because most people are just assembling, getting the cells and then putting them into modules, right? Are you making the cells here?
This day is all about making battery cells in India, right? And that's what we have done. We have put up the first facility which can manufacture cells, and we have made the first lot of cells as well. And you've seen that those cells go into a battery pack, and then battery pack go into a two-wheeler and drive through. So we have shown that it is possible in India, and now we'll scale it further from there.
Yeah. So I saw you talking about those steps, and I wanted to just go back a little bit from nanotechnology to a cell manufacturing plant. It's quite a journey, and how has that been, and what have been the challenges, and how did you envision this? I mean, how did it go from there to there?
So very frankly, when we started Log9, cell, battery or EVs was not even on our horizon. Forget about India's horizon itself, right? So nobody was talking about EVs, nobody was talking about batteries, and we ourselves didn't have a vision of doing batteries. The vision that we had was that how can we create deep tech technology, especially around materials and carbon materials in India. That's how journey started. Very soon we realized that we need to leverage these materials for creating innovations and products for the country, and particularly the ones which are long-term sustainable from an environmental perspective. And that kind of pursuit led us into batteries, because if you look at all the carbon emissions in the world that happen, 2/3 of that is directly or indirectly attributable to energy use. And if you really have to transition to green energy, then storage is important, whether it's storage for storing solar power, or it is storage in your basically battery in your electric vehicle is the same storage battery. So that needs to really be built, and it needs to be built as per Indian requirement and conditions. So that's what we are trying to do here.
Fantastic. Can you tell us a little bit about the LTO technology? Because you hear NMC, you hear LFP, but LTO is not, something that we're talking a lot about in India. So why that technology did you go for? What prompted you to go and say, okay, this is the technology I'm going to work with first?
So first of all, we work and we have developed both technologies, LFP and LTO. Why we have chosen these two chemistries as compared to NMC or anything else is because these two chemistries are very, very temperature resilient. LTO is the most resilient technology. You can cut it, you can throw it in an oven, it won't catch fire, it won't blow up in your face, and you can charge it very quickly. LFP is resilient as well, much more than NMC, slightly less than LTO, but it works for various applications in India. So between LFP and LTO, you can serve the entirety of applications, whether it is for mobility or stationary. Now, where LTO works is for your short haul, intra-city commercial applications. Now, that segment is very different. It's very unique to India, right? Yeah. Two-wheelers, three-wheelers, small four-wheelers is something which is very unique to India and the tropical belt, right? So you cannot really say that stuff which is working in Teslas and other kind of vehicles of the world will directly be kind of usable in this in the country and in this region, right? And in these vehicles. So that's where a fundamental approach of which kind of chemistry is relevant for commercial short haul intra-city applications is where LTO emerged, because this technology can be charged very quickly. Okay. You can practically charge a vehicle with LTO battery in less than 5 minutes time, right? So that kind of gives you a very quick turnaround, and you can do multiple shifts. So it becomes very important for commercial application. At the same time, no matter how much you use it, it will last for more than 15-20 years. Yeah. So the vehicle owner is not worried about that, oh, if I do more deliveries, then my battery will die down faster, and then I have to go for battery replacement. Yeah. So the combination of these factors, it made a lot of sense to kind of bring LTO to India, pioneer that. And I think if you look at by sheer number of vehicles, Log9 deployed vehicles is the largest example of LTO utilization in the entire world.
Yeah. But there are also challenges to LTO, as I'm given to understand. I mean, it's not all roses like you're making it out to be. There's a lot of weight, because it's an energy, it's a low density battery, so you have to get a lot more weight. So how did you manage to balance that? Because in the area you're talking about two-wheelers, you need something that's swappable, you need something that's small, something that's easy, and not a lot of weight. So how did you manage to counter those challenges? And despite those challenges, you still went for this technology?
So I'll take this question in two parts. One is that how do we manage that this kind of energy density and this kind of weight of the battery in the vehicle. So one of the thing is that, as I mentioned, it works for intra-city short haul applications. So sub 100 kilometer range vehicle range requirement is where this works brilliantly, because in that case you're not bulking up too much weight on the vehicle.
Okay.
And for that vehicle segment with LTO batteries, the increment in the vehicle overall vehicle weight is less than 6-7%.
Okay.
So from that perspective, it doesn't really impact the performance of the vehicle. Actually, the performance improves because the battery is more powerful, so it can carry more load.
Okay.
Right. And it doesn't matter whether you're climbing a flyover or going down a tunnel or anything like that. So that is able to be managed. Also with LTO, you need smaller batteries. Okay. Like the overall capacity can be smaller because it enables you to have much higher efficiency on regenerative braking.
Okay.
So the energy that you get back when you brake an electric vehicle, you can absorb much more current in an LTO battery as compared to LFP or NMC. So as a combination of these factors, we are able to manage that weight requirement for these short haul vehicle applications, and in turn you get all the benefits that I mentioned. On the swapping part, right, all batteries need not be swapped. And in general, if fast charging was possible earlier, swapping would not have come as a concept.
Yeah.
Right? It's a very classical example of Jugaad.
Yes.
Right? That, I can't solve it with technology, I can't solve charging time with technology, so let me deploy more assets to it. Let me deploy more batteries, have more batteries in the ecosystem, so I swap one and swap in another one. But overall, the scalability of swap solutions is something which is challenging, and that's the reason you don't see it scaling up across the world anywhere. Apart from one example of Gogoro, there's no other successful example of that.
And that leaves you with a bigger problem of battery scrapping, which is
exactly
a larger problem that we'll come to a little later. But you spoke about charging and fast charging. Now that is another area that you have diversified into, and energy storage solutions, like you said, and charging infra and rapid charging. But there are challenges in our country. Grids can't handle it. The power supply available that's needed for a fast charger itself is often not there. I know that boosters are being used, things are being done. But how difficult is that, and what are the challenges, and how do you see that future panning out? Is it realistic?
See, charging infra is a global problem.
Yeah.
Right? So, in India, it becomes even more exemplified because of our, as you mentioned, right, the grid is not that sophisticated. There are multiple levels of efficiency and infra issues on the overall grid. But there is no way around it. You can't say that, because the grid is not there, we will not do EVs. Right? That is not an option that we have. So we will have to work towards in strengthening that charging infra problem. Also, what it requires is a holistic approach by the players in the ecosystem to see it in a complete spectrum, right? It's not like I make batteries and I sell it and forget about it. If you take that approach, the ecosystem will not grow, right? How do you choose the right applications where the charging infra can grow more sustainably? How do you work and incentivize the charging infra players? We don't put up a single charger ourselves, but we work with other partners to make sure that this ecosystem grows. And that's why commercial utilization of electric vehicles become very important, because if you have a commercial vehicle, these vehicles will always be utilized in a certain pocket of the city. So you will know in which part of the city how many vehicles are there, and because they have fixed timings of deliveries and shifts and all of that, right? So you will know which vehicle will turn up when for charging, and we have all that data, and we are able to provide that data to our partners who basically are in the business of setting up chargers, so they can precisely put up a charger where it is required, rather than having to kind of put up chargers everywhere, right? So that becomes chicken and egg. So you have to solve the chicken and egg. The way to solve it is put charger where the vehicle is there. And with commercial mobility, that is possible. And once the infra scales, then anybody can use it.
But I think the bigger question of mine was, you made some, you all spoke about 5 to 45 minutes. Now I'm assuming that is predominantly for two-wheelers, because it's hugely unrealistic at this point of time for four-wheelers because of larger battery sizes, that. But do you see that actually happening in the future? Because your statement was, we want it to be as easy and quick to charge as an ICE engine, right? How far do you think that is, given our current scenario?
So timeline is something which we have to see how quickly it develops. It has to come up very fast. at least in the two-wheeler and three-wheeler in the small vehicle space, it is picking up very, very quickly. And given the kind of utilization that we have been able to show in the charging infra, many partners are now seeing it as a profitable, sustainable business, right? If you look at charging infra utilization, before we were able to enable two-wheelers and three-wheelers to charge on like your public fast charging stations, it was less than 7-8%. Today it is at 45-48% with our vehicles turning up to these stations. So that utilization has to grow stronger, and we have to break that chicken and egg, as I mentioned, right? Now the trend obviously is going towards faster and faster charging globally, right? Also to the point that if you have to basically make this win, you have to basically, nobody wants to wait 2 hours, right? I'll use the mobile phone industry in that case, right? Moment the mobile phones were able to charge in less than an hour, nobody wants to plug them at night. Right? Nobody wants to wait for 3-4 hours for their phone to charge. It will always be while you're taking a shower, my phone should get charged. Correct? So that same user experience is important in the electric vehicle space as well. And what happens is charging infra is not just about the charger, it is also about the real estate, right? So if you don't have a quick turnaround time of vehicles coming and going, right, you will not have a charging infra which is profitable.
It's also about the battery tech and the ability of the battery to hold and be sustainable for that rapid charging. We've seen a lot of problems in the country already, and a lot of people today, when I tweeted about this plant, the first comment of a lot of people was, I hope that they make the battery stable. So tell us a little bit about that and how your batteries are different from the rest, how you ensured safety.
So safety is something which is primary focus for us, and that is, so safety has various tenets, right? It's not just about the batteries not blowing up, but it's also about the confidence that I am using an asset or a product which is reliable, right? Safety is also personal in that sense. It should not happen that I'm going on the road and it stops working, right? There should be predictability in usage. So all of those things, and there have been incidents where electric vehicle was going up with load, like three-wheeler was going up with load, and the battery failed on the way, the vehicle started coming back on the flyover, right? So that is also part of safety. So the resilience and consistency of performance, along with it not blowing up in your face, are important tenets of safety. And the way we have done is as we mentioned in the presentation as well, it's a mix of 3-4 things. One is that how do you manage the chemistry, design and manufacturing of the cell, and then how do you manage that cell at the battery pack level. So you have to solve each of these nodes to be able to provide a cell which is safe and can be charged very, very quickly. So the right choice, so for example, LTO is very safe at the chemistry itself. Now, as we discussed, LTO cannot be deployed for every application. So how do you make LFPs equally safe and at the same time rapid charging and high performance? So you have to work on the chemistry part. You have to basically come up with additives in electrolytes, in the cathode material and in the anode side. And then on the cell design, how do you make sure that as you're fast charging it, there's not a lot of heat being generated. So there has been work which has been done at Log9 on that front by pioneering tabless technology in the country, right? And then managing all of that at the battery pack level, right? So a lot of people think that just by cooling the cell or cells enough in a battery pack, you can charge it at whatever rate you want, but that's not the case, right? We have shown data today itself that even if you put it in an infinite cooling bath, right, the cell will blow up if you try to charge it, charge it very fast. So you have to manage fast charging by the right kind of battery management system, the right smartness, managing multiple cells in the battery pack at the same level of charge and discharge, and at the same time working towards how do you see what is the degradation level of the cell over its life.
Correct.
So mapping the life cycle of the battery and the cell in the vehicle is also very, very important. So all of that data comes back to us, we are able to analyze it, we are able to monitor the performance of the battery on field.
And so you made your own battery management system as well. So it's not just making the cells, you've delved into the whole ecosystem around it. It's completely different. It's a little bit different. It's a lot more of software. It's a lot more, it's not nanotechnology. So how does that all work in your ecosystem, and how come you went along that path of now I want to develop this as well?
See, there were a lot of gaps the way we were seeing in the battery management system space, and we have been able to, and we have got really great team together in terms of building battery management systems, and they've been able to put all of that together. Also miniaturize multiple chip boards. What was happening in the ecosystem was that there was a separate chipboard for the charging connection, there was a separate chipboard for motor controller, there was a separate chipboard for telematics, a separate chipboard for BMS. Why do you need so many different ICs and components in case anyway semiconductor industry has been going through a constraint,
exactly, yeah.
and then you're putting multiple of them for no
Yeah.
purpose. So how do you integrate all of them? When you integrate all of them, you're managing all the pieces and nodes on at one place. So you have better control and better visibility, and then communication is better between different functions of the same board. So that is all which has been designed over here, and it is first a hardware problem and then a software problem, right? So hardware has to be solved. How do you put all of that together, and how does it communicate with the battery and then front to the motor, and then the software like comes in, like what algorithms are coming into the picture. So over time that competency has been built at Log9. It came out of the need that we are not able to get the best products out there just by procuring or sourcing them. So it needed to kind of work with the battery in the right fashion, and then now we're going a step further where we have partnered up with companies like Chara, for example, to provide an integrated solution that you have the battery, the BMS, which includes all the management systems, and the motor as well combined together in a powertrain solution, which then I can take the ownership of reliability and confidence.
So you've also had tie-ups with people like Kinetic Green. So will you now look at providing like this entire solution to people who are developing?
Kinetic, we don't have a partnership,
no?
sorry.
Okay.
But yes, we work with a lot of two-wheeler, three-wheeler manufacturers in the country. So yes, we're working with them to provide an integrated solution, right? Because if you're not aware, see, nobody wants to take ownership. If you're just importing components, right? The person who's supplying sitting somewhere else in the world, more often than not will not take ownership of performance of that component in Indian conditions.
Correct.
And that is what we have seen consistently. When all these fires happened and all these issues happened with EVs, none of the primary suppliers came up and said, oh, we messed up here, or it was our responsibility as well, right? All the heat of that was faced by the OEMs,
correct,
right, which had very limited visibility into how that cell was made or how the battery was made. Right, so from that perspective, unless we do it here and we are able to integrate that solution, it will continue to be the case like we have seen in the last year. Okay,
so you will look at providing this cohesive solution to manufacturers now, there are so many players coming into the EV space, and are you looking purely at two-wheeler, three-wheeler, which has been your focus so far, or are you also looking to diversify into four-wheeler space? Because you have the BMS, you're working with the motors, you've got the battery technology.
So it's not just two-wheelers and three-wheelers that is the focus, so to speak, but that is the market which we started with. Obviously that's where the demand was there in the Indian ecosystem, but we already have launched four-wheeler battery solutions. We have launched solutions for forklift application or industrial vehicle, tow trucks and stuff like that. And then we are working with our partners, vehicle manufacturers in the ecosystem for bus and truck applications as well. So as the market matures up in different segments, there will be battery solutions available from Log9. Right, our batteries, we are able to design batteries from as small as a 3 kWh, 2 kWh battery pack for two-wheeler to all the way up to 60, 80 kWh as well. And then we are designing 200 kWh, 300 kWh battery packs for buses and even stationary energy storage applications. Are you using different chemistries for those? Because you're also developing new chemistries. So chemistries is the same. So it will always be a mix of LFP and LTO depending upon use cases, right? Whether LFP makes sense or LTO makes sense. But building larger packs also requires more intervention at the battery pack level. Right? There's only so much that one BMS can control. Then how do you have a master BMS and a substructure? So how do you create that stack and then build larger and larger battery packs? Also, as you go towards larger battery packs, voltage increases. So you have a shift from sub 100 volt platforms to about 300 volt platforms, and then there's a different world altogether. And then it requires different thermal management. So all of that stack is being built at Log9 to ensure that as different segments get unlocked in the Indian market, we are able to provide the right solution for tropical applications. You've also invested a lot in aluminium, air, and because you're looking at that for long haul commercial applications. Right. So tell us a little bit about that. So aluminium air is actually where our journey in the battery space started, right? We were caught by the bug, so to speak, to solve all challenges of electric mobility in India at once, right? So if you think about challenges at that time, what the challenges were: I want more range, I want something which can be refilled or recharged very, very quickly. I want to have something which does not matter if it's 40 degrees outside or 60 degrees Celsius outside. I don't want supply chains which are dependent on lithium and cobalt and stuff like that. So while it solved on all these challenges, or so to say issues, There are some issues which we were not very focused on at that time, and we didn't realize that because of these issues, it cannot be deployed across all applications, right? So any fuel cell system, whether it's our aluminum fuel cell or whether it is a hydrogen fuel cell system, has the biggest drawback, which is of energy efficiency.
Correct.
Right? So these systems only make sense where the batteries, which are 90-95% plus efficient, don't really give you the right application or right performance in terms of range or any other kind of issues. So that is where they come in. Long haul mobility is one application. Your replacement for diesel generators, which we are targeting as the first application of that technology, right, is going to be a big market, because in power backup or grid storage, you can solve for 95% of uptime of power available by batteries and solar and all of those things. But the last 5% is very dynamic. So for that, you need something which can come up and go back off in a very dynamic way, and that is where you need systems like diesel generators today, and those diesel generators need to be sustainable, so AFC and that kind of technologies tomorrow.
Great. What is the manufacturing capacity of this facility?
So the cell line that we have inaugurated today has a capacity of 50 megawatt hours. Just for everybody's sake of understanding, this is enough for around 8,000 three-wheeler battery packs being deployed every year.
Okay.
Yeah.
And what kind of volume increase is the company expecting with this new facility?
So 50 megawatt hour is on the cell side. We already have our battery pack manufacturing facility, which is already 250 megawatt hours, so 5 times of that. This is just a first step towards cell manufacturing in India. So we'll scale up this facility to a gigawatt hour in the next 2 years time period. That is what we're going to work on going forward, while the battery pack manufacturing further scales up. And the idea is that replace the current supply chain of importing cells with our own produced cells.
Yeah. I can imagine that the order book must be looking pretty good, because you're the first mover in this segment. So are you booked up for the next year, or how does the order book of the company
We have
look?
more orders than we can support, both from the cell level and the battery pack level. Okay. But it's also a matter of building up in a sustainable way, right? Because if you scale too fast, then there will be issues with the product, and then you will not be able to manage it in the field. And we have a very hands-on approach when it comes to providing batteries to our partners who make vehicles, and then further people who use those vehicles. So in that sense, we are scaling. I would not say we're scaling slow. We have been very rapid with our scale, but also being cognizant of it comes with responsibility.
Okay. What are the other green mobility sectors you're looking to explore?
In terms of green mobility, when you say, what do you mean?
Beyond two-wheelers, three-wheelers, like you said, storage solutions, right?
Yes.
So what are the areas of the ecosystem you're looking to expand into?
See, if you, as I said, like two-wheelers, three-wheelers is a big market already in India. Four-wheeler is picking up, both on the passenger side and the cargo side. Then we have bus and truck applications on mobility. And then you have industrial vehicles, right? We ignore them quite a bit, but they are also a big contributor to the whole carbon emissions play in the industrial manufacturing processes. So that segment is there. But apart from mobility, there is an equally huge and very large opportunity in the stationary energy storage space. When we talk about electric mobility will provide us no green benefit unless and until we use clean electricity to charge it.
Yes.
And clean electricity cannot come without batteries again. So you can generate solar, but only generates for 4 or 5 hours in a day. What do you do for the next 24 hours? So you need to have extra capacity on solar and then store that energy in those 4 or 5 hours to supply for the next rest 24. That's where batteries come in. And if you have to do that by 2030, the Prime Minister has already announced 500 gigawatt of renewable energy generation on the grid. That would at least require 250 gigawatt hours of batteries to be deployed.
Correct.
Right. So while a lot of them will still be imported, but you would need capacity to grow further, because 2030 is not a stop.
Yeah.
Right. It's just a beginning again to kind of further scale and go to our 2070 net zero goals. So from that perspective, a huge amount of batteries will be required for stationary applications. So there's still a market maturity that needs to kick in the stationary space, but I'm sure within the next 2-3 years you will see a huge tick off in the stationary market as well.
Okay. And as the company is expanding its footprint, are you looking at another round of funding?
See, I think in the startup space, it's a vicious cycle, right? You raise once, then you have to perpetually keep on raising and growing till you're large enough and you get into a profitable zone, and the manufacturing of the products and selling of the products can take care of the growth of the company. So I think we are a couple of years away from reaching that scale and that stage. And obviously a lot of investment goes into setting up this kind of R&D facilities and developing technology. So that's where obviously we'll have to raise, we have raised $40 million by December as part of our Series B. We will be announcing soon more capital raise in our Series B itself. And then next year we'll raise our Series C for further scale and growth of cell manufacturing in India.
Okay, perfect. You spoke about some partnerships that you have which are very strong. And you spoke about them a lot, like you said, for the motors, for the external things. But are you also looking at partners like SIDAC? You said that when you went to their labs, you found that there were a lot of future technologies that they were working on. So you're looking at cell chemistry partnerships in that area as well?
Yeah, so cell chemistry, battery pack level technologies like thermal management or electronic architecture, power electronics, as you mentioned, SIDAC is a very great example of that. So what we have seen, and there was the large cohort or a roundtable that we hosted yesterday with various academic centers and research centers in India. I think one of the big missing pieces is that a lot of innovation actually is happening in the country, which we don't know and kind of are aware about, but it kind of remains in the labs itself. And the reason for that is that it is tested at a very component or a small level.
Yes.
And there is no place or opportunity to kind of take it to a POC level where it can actually take a shape and form which can be applied in the market.
Okay.
So that came as a feedback to us from various stakeholders in the research and the academic space, that can Log9 create a center, can Log9 create a facility or provide an opportunity where the technology that we're developing at a small scale in our labs can be brought, right? And then they can be transformed into a proof of concept. And then whether Log9 can absorb it or we can take it to somewhere else, but at least the technology base grows. And right now in this ecosystem, I don't feel that even 10 more companies will be a competition, because the opportunity is just massive. Right? And unless and until the ecosystem grows, you can't grow. It's like in a desert, the trees are all short.
Exactly, yeah.
Right? So
no, and it's always good to have, I mean, I think as you get more players, the entire environment grows with it, right? So you do need more players to come into the segment. And you spoke a little bit about a partnership with Bosch, but I wasn't exactly clear, because you said we're working with them. I mean, that's where I was talking about battery swapping and residual factor back. So is that an area you're looking at working on with Bosch? Or?
So with Bosch, we are working on solving the confidence around electric vehicles being a challenge in the ecosystem.
Okay.
See, the challenge is the financiers are not sure whether the asset will last as long as it is supposed to. The users are not sure whether the performance will be enough, what will the load bearing capacity, and how long will the battery last, right? The people who are basically giving insurance, they are not sure whether the driver is trained enough to kind of use the electric vehicle in the right shape and form, right? And at the same time, the user is also not sure that where I will charge it and how long it's going to take and all of those things. So we are connecting all of these nodes together and working with Bosch to kind of create a blockchain network to basically create confidence in the ecosystem. That, okay, you have this confidence issue, this is the person who can solve this confidence issue, so they become responsible. So for example, if the financier has an issue, then we as battery manufacturer, we give a responsibility to say that yes, it is my battery and I take ownership and responsibility to make sure that it will last as long as it should. And then creating a data pipeline all around it to manage this confidence. That monitoring, having real-time data coming in from the batteries to say that, okay, this is the residual life, this is what is left, this is what is a problem or it can be rectified. And then also mapping it to driver behavior.
Okay.
Right, so saying that, okay, and incentivizing the drivers to use EVs in a more efficient manner. Right, so taking data again, that how the vehicle is being driven, right, who is a better driver, who understands better, and then creating awareness on that side. So that is what we are trying to stitch together to facilitate ecosystem and more like basically making utilization of EVs more efficient.
Create an environment in which you know there is a confidence for
investors
to come in,
you can use EVs
and
better.
Consumer to have the confidence, and it needs both to build the bricks of the industry. Great. So back to that question on scrappage, and is that an area that you're looking to work on, develop, because that, as you said, the responsibility of being green is at both ends, from the charging to the end. So is that an area that you see Log9 also getting involved in and finding solutions for?
So we are not directly involved, but we have been supporting and growing a company called Metastable Materials. They have come up with a very efficient process of recycling lithium-ion batteries. So we are constantly advising and helping them to grow that piece. And what we don't realize is that recycling is not only a piece which makes it more sustainable and green, but it also provides supply chain security. Because if you go into recycling, you can more efficiently use what you already have as materials locked into old batteries, and that kind of gets pumped back into the ecosystem. So it is important from both sourcing and supply chain management perspective, as well as for making the whole process more green.
Perfect. My last question to you. You started with the dream of nanotechnology. You've grown it along the way. What's next? What's the big goal?
See, the big goal is that none of the battery players globally, like battery leaders at a global level, are focusing on India and the tropical belt. So basically Southeast Asian market, the African, Middle East, Latin American market, right? Our needs, our vehicle types, our usage patterns are very different. Our weather conditions are very different. And while these players are not focusing on this market, there is an opportunity for a company like Log9 to kind of serve the needs and custom needs of this market and then emerge as a battery leader of the tropical world tomorrow.
Perfect. Congratulations. Wish you all the best, and thank you so much for this conversation.
Thank you.